let's go ahead and get started. Today we are doing Chapter 5, Lesson 6, and we are using the Pythagorean Theorem. Our learning goal is that students will be able to use the Pythagorean Theorem, and these are our two standards that we are working with this lesson. Make sure to write down absolutely everything that is typed or written in these videos, and make sure that you pause this video at any time that you need to slow things down. Okay, for this page, what you need to write is down here at the bottom, okay? And up here at the top, this is on page 412, so you may want to make a note in your notes that this is on page 412. What you really need to know is that C is the hypotenuse and the longest side. So here's the hypotenuse and the longest side. A and B are the L length, okay? A and B are the L of the right angle. So A squared plus B squared equals C squared. That is the Pythagorean theorem. Make sure that all of this is written down before you move on with this. Alright, so a party hat is in the shape of a cone with dimensions shown. Okay, find the height of the hat and round to the nearest tenth. So here is a triangle. Okay, and here is the L shape. I'll do that in red. This is the L, so that's the A and the B squared. So we only know one of those. So we'll say this is A, B, and C. So our formula is this. And we need to insert in the numbers that we have. So we don't know A squared, but B squared, we've got 4.3 squared. And then C is 10, so we've got 10 squared. So 4.3 times 4.3 is 18.49. We need to bring down our A squared. And then 10 squared is 10 times 10, which is 100. To solve this, we need to first start out by subtracting 18.49 from both sides. This cancels, and we are left with A squared on the left, and 100 minus 18.49 on the right, and that is 81.51. And we need to get the square root of that, because this is A times A gives me 81.51. So to find A, we need to find the square root of 81.51. So you can press that button on your calculator. And this gives us a really long decimal, but we can round it to the nearest whole number. Oh, it says round to the nearest tenth. Sorry, this is what I get for reading directions. All right, so we need to round to the nearest tenths place. So if I've got 9.0028, the tenths place is the 0. So we need to look back at the 2. That 2 is not enough to bump that 0 up, so it's going to stay the same. So it is 9.0, and we are talking about inches here. So 9 inches. Okay, this says Larry wants to go from his house to his grandmother's house. How much distance is saved if he takes Main Street instead of Market and Exchange Street? So this is in your book on page 429. You don't have to draw this diagram or write this part of the problem, but you do need to remember that it is on page 429, so write that down and write down that it is problem number 14 on that page. Okay, and then everything else I'm about to write, you need to write that as well. All right, so it says how much distance is saved. So we need to figure out what this D is, and then we need to add it to the 3 blocks and then subtract the 5, because we want to know how much longer it is going here and here than it is going straight across. So A squared plus B squared equals C squared. That's our formula. And we know that 5 is our hypotenuse, so 5 squared. B we know is 3 squared, and we are looking for A squared. So 3 times 3 gives us 9, and 5 times 5 gives us 25. So to start solving this, we need to subtract 9 from both sides. This cancels, and we're left with a squared on the left, and 25 minus 9 on the right, which is 16. To solve this, we need to take the square root of 16, and the square root of 16 is 4, because 4 times 4 gives us 16. So our answer, we're not done yet. Our answer to D is that it is 4 blocks. But it wants to know how much distance is saved, meaning we need to add up these two and then subtract the 5, and that'll tell us how much is saved. So the 3 plus 4 gives us 7, and 7 minus 5 gives us 2. So we will save 2 blocks by going straight on Main Street than we would by going on Exchange Street and then to Market Street. Okay, suppose Greenville, Rock Hill, and Columbia form a right triangle. What is the distance from Columbia to Greenville? So we've got 80 miles here from Greenville to Rock Hill, and from Rock Hill to Columbia is 68 miles. So we've got 80 squared plus 68 squared equals c squared. We do not know the hypotenuse, which is here. All right, so 80 squared, 80 times 80 is 6,400, and 68 squared is 4,624 equals c squared. So we need to add up those two numbers. Okay, so we've got 11,024 equals c squared, and to find what c is equal to, we need to get the square root of this number. Okay, and it is a really long number. So we are going to round this to the 10th place, even though it doesn't ask us to. Okay, when we are rounding to the 10th place, I like to underline the place value that we're rounding to and look back at the number behind. This 9 is enough to bump this 9 up. So this 9 is going to become a 10. So put our 0 down, add your 1 to the next column. 1 plus 4 is 5. So instead of 104.99, it is now going to be 105.0. So 105 miles in between Columbia and Greenville. Okay, and last problem. It says Meredith, and this is on page 426 in your book. Meredith made a model of a pyramid like the one shown for history class. What is the height of the model? So it's hard to kind of see this, but this is our hypotenuse. This is the bottom, B, and here is A. We do not know A. That's what we're looking for. So A squared plus B squared, our B is 9, so 9 squared, equals C squared, which is 15, so 15 squared. So A squared plus 9 times 9 is 81, equals 15 times 15, which is 225. To go about solving this, we need to subtract 81 from both sides first. This cancels, and we're left with A squared on the left, and 225 minus 81, which is 144, and the square root of 144 is 12, because 12 times 12 gives us 144. So my answer is that the height is 12 inches. Okay, that's all I have for you guys today. I hope you guys have a fantastic day, and I will see you tomorrow.